Introduction to Private Service Connect. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Today, we're diving deep into Private Service Connect, or PSC, one of the most powerful yet often misunderstood networking features in Google Cloud Platform. PSC fundamentally changes how you expose and consume services by providing a private, secure, and scalable way to connect services across VPC networks without exposing them to the public internet. Think of Private Service Connect as a next-generation approach to service connectivity. Unlike VPC peering, which connects entire networks, or traditional load balancers that expose services publicly, PSC allows you to publish specific services and have consumers access them through private endpoints in their own VPCs. This granular control is revolutionary for enterprise architectures. PSC addresses several critical challenges: how to expose services without opening entire networks, how to maintain IP address independence between producers and consumers, how to scale service access without complex firewall rules, and how to provide managed services privately. By the end of this presentation, you'll understand why PSC is becoming the preferred method for private service connectivity in GCP. Private Service Connect operates on a producer-consumer model with three main components. First, we have service attachments on the producer side. These are configurations that expose your services through PSC. Second, we have endpoints on the consumer side. These are IP addresses in the consumer's VPC that connect to the service. Third, there is the PSC infrastructure itself, which handles the secure connectivity between producers and consumers. The beauty of PSC is that it creates a complete network abstraction layer. Producers publish their services without knowing who will consume them, and consumers access services as if they were local to their VPC. This decoupling is achieved through Google's software-defined network, which manages the connection without requiring any direct network path between the VPCs. From an architectural perspective, PSC uses a forwarding rule on the producer side that points to a service attachment. This attachment is associated with a load balancer, either an internal TCP/UDP load balancer or an internal HTTP/HTTPS load balancer. Consumers create endpoints in their VPC that map to these service attachments, and Google's network fabric handles the secure routing of traffic. What makes this particularly powerful is that each side maintains complete control. Producers can approve or reject connection requests, implement connection limits, and monitor usage. Consumers get a stable IP address in their VPC that never changes, regardless of what happens on the producer side. This stability is crucial for applications that need predictable endpoints. Private Service Connect comes in three distinct flavors, each serving different use cases. Let's explore each type in detail. First, we have published services. This is when you want to expose your own services to other VPCs, whether in your organization or external organizations. You create a service attachment behind an internal load balancer, and consumers connect through PSC endpoints. The second type is PSC for Google APIs. This allows you to access Google services like cloud storage, BigQuery, or pub/sub through private IP addresses in your VPC. Instead of accessing these services over the internet, you create PSC endpoints that provide private, low-latency access. This is particularly valuable for security-conscious organizations that want to avoid internet exposure. The third type is PSC backends for hybrid connectivity. This is used when you want to access on-premises services from Google Cloud. You can create PSC network endpoint groups, or NEGs, that point to on-premises IP addresses accessible through Cloud VPN or Interconnect. This enables hybrid load balancing scenarios where Google Cloud load balancers can send traffic to on-premises backends. Each type has its own configuration requirements and use cases, but they all share the core PSC benefits: private connectivity, IP address independence, and granular access control. Understanding when to use each type is crucial for architecting effective solutions. Private Service Connect offers numerous advantages over traditional connectivity methods. The most significant benefit is true network isolation. Services are exposed without opening firewall rules or establishing network peering. This dramatically reduces the attack surface and simplifies security compliance. You're essentially creating a one-way door that only allows specific, controlled access. Scalability is another major advantage. With traditional methods, you might need to manage numerous firewall rules, VPN, connections, or peering relationships as you add consumers. With PSC, you publish once and can have hundreds or thousands of consumers without any additional configuration on the producer side. Each consumer manages their own endpoint independently. IP address management becomes much simpler with PSC. Consumers can choose any available IP address in their VPC for the endpoint, eliminating IP overlap concerns. This is a game changer for organizations with complex IP addressing schemes or those integrating with multiple external parties. The producer's IP addressing is completely hidden from consumers. From an operational perspective, PSC provides excellent observability. You get detailed metrics about connections, traffic patterns, and usage. Cloud logging captures all connection events, making it easy to audit who is accessing your services. This visibility is crucial for troubleshooting and capacity planning. Let's walk through setting up a published service with Private Service Connect. The process starts on the producer side where you have a service running behind an internal load balancer. This could be an internal TCP/UDP load balancer or an internal HTTP/HTTPS load balancer, depending on your service requirements. First, you create the service attachment using the gcloud command. Gcloud Compute Service Attachments create my PSC service, region as Central 1, producer forwarding rule my ILB, forwarding rule, and connection preference accept automatic. The connection preference determines whether you want to manually approve each consumer or automatically accept connections. Next, you need to configure NAT subnets for PSC. These are special-purpose subnets used exclusively by PSC to allocate IP addresses for the connection. You must create these subnets with the purpose set to Private Service Connect and they should be at least /29 in size. The command looks like this. Gcloud Compute Network Subnets create PSC, NAT subnet, network my VPC, region as Central 1, range 10.1.0.0/29, and purpose Private Service Connect. On the consumer side, the process is simpler. They create a forwarding rule that points to the service attachment with the command. Gcloud Compute Forwarding Rules create my PSC, endpoint, region as Central 1, network consumer VPC, address PSC, endpoint IP, and target service attachment project/producer project/region/is Central 1/service attachments/my PSC service. Once created, the consumer can immediately start accessing the service through their chosen IP address. PSC for Google APIs. Private Service Connect for Google APIs is a game changer for organizations that need private access to Google services. Instead of accessing cloud storage, BigQuery, or other Google APIs over the internet, you can create private endpoints in your VPC. This provides several benefits: reduced latency, improved security, and simplified network architecture. To set this up, you first need to create an IP address for your endpoint. Gcloud Compute addresses create Google APIs PSC region US Central 1 subnet my subnet purpose Private Service Connect. Then create the forwarding rule. Gcloud Compute Forwarding Rules create Google APIs endpoint region US Central 1 network my VPC address Google APIs PSC target service attachment projects/p cloud services/global/service attachments/Google APIs default. One of the powerful features is the ability to create custom DNS zones that automatically resolve Google API domains to your PSC endpoint. For example, you can make storage.googleapi.com resolve to your private endpoint IP. This means existing applications work without any code changes, they just automatically use the private path. Google provides pre-configured service attachments for different API bundles. The All APIs bundle includes most Google APIs, while you can also choose specific bundles like storage only or BigQuery only if you want more granular control. This flexibility allows you to minimize the attack surface by only exposing the APIs you actually need. Common use cases and patterns. Let's explore real-world scenarios where Private Service Connect shines. One of the most common patterns is the SaaS provider model. If you're offering software as a service, PSC allows you to expose your application to customers privately. Each customer gets their own endpoint in their VPC, maintaining complete network isolation between customers. You control access through the connection approval process. Another powerful pattern is the shared services architecture within an enterprise. Your central IT team can publish services like authentication systems, data warehouses, or monitoring platforms through PSC. Different departments or projects consume these services through their own endpoints, maintaining network segmentation while enabling service sharing. For hybrid cloud scenarios, PSC backends enable sophisticated architectures. You can have Google Cloud load balancers distribute traffic between cloud and on-premises backends seamlessly. This is particularly useful during migrations or for applications that need to remain partially on-premises due to regulatory requirements. Multi-cloud connectivity is another emerging use case. While PSC itself is GCP specific, you can combine it with other technologies to create private connections to services in other clouds. For example, you might have a VPN to AWS and expose those services to other GCP projects through PSC, creating a hub-and-spoke multi-cloud architecture. Security is where Private Service Connect truly excels. By design, PSC provides multiple layers of security. First, there's no direct network path between producer and consumer VPCs. All communication goes through Google's secure infrastructure. This eliminates entire classes of network-based attacks and simplifies compliance auditing. Access control happens at multiple levels. Producers can implement allow lists to control which projects can create endpoints. They can also set connection limits to prevent any single consumer from overwhelming the service. On the consumer side, you still apply your normal firewall rules and IAM policies to control who can access the PSC endpoint within your VPC for compliance. PSC provides comprehensive audit logging. Every connection attempt, approval, and rejection is logged in cloud audit logs. Traffic flows can be monitored through VPC flow logs. This visibility is crucial for regulated industries that need to demonstrate control over data access and movement. One particularly valuable security feature is that PSC endpoints can be placed in different VPC service controls perimeters than the services they connect to. This allows you to create sophisticated security boundaries while still enabling necessary connectivity. For example, you might have a high security perimeter for production data but still need to expose certain services to development environments through PSC. Troubleshooting and best practices. When troubleshooting PSC connections, start with the basics. First, verify that the service attachment exists and is in the active state with the command G-Cloud Compute Service Attachments describe my PSC service region as Central 1. Check that the producer's load balancer is healthy and the backends are responding. Remember, if the underlying service is down, PSC cannot magically make it work. On the consumer side, verify the forwarding rule is created correctly and points to the right service attachment. A common issue is a typo in the service attachment path or an incorrect project ID. Use the G-Cloud Compute Forwarding Rules describe my PSC endpoint region as Central 1 command to check the configuration. For connectivity issues, check firewall rules on both sides. Even though PSC provides network abstraction, firewall rules still apply. The consumer needs egress rules allowing traffic to the PSC, endpoint IP, and the producer needs rules allowing traffic from the PSC, NAT subnet ranges. VPC flow logs are invaluable for debugging these issues. Best practices include using descriptive names for your service attachments so they indicate their purpose. You should also implement connection limits to prevent abuse, and monitor connection counts and bandwidth usage. For production services, use the accept manual setting to control access. And finally, be sure to document your PSC, endpoints and their purposes, and regularly review connected consumers to remove unused connections. For certification exams, it's crucial to understand the key differentiators of Private Service Connect. Remember that PSC provides service-level connectivity, not network-level like VPC, peering. It's unidirectional, so consumers can reach producers, but not vice versa, unless you configure another PSC connection in the opposite direction. Common exam scenarios involve choosing between PSC and VPC, peering. Use PSC when you need to expose specific services without opening your entire network, when you need to maintain IP address independence, or when connecting across organizations with different security requirements. VPC peering is a better choice for scenarios that require bidirectional, full network connectivity. You should know the three types of PSC and when to use each. Published services for your own services. PSC for Google APIs for private access to Google services, and PSC backends for hybrid load balancing. Each has specific use cases and configuration requirements that are often tested. For the key technical points, remember that PSC requires a NAT subnet with its purpose set to Private Service Connect. Also, service attachments are regional resources. Endpoints consume IP addresses from the consumer's VPC, and connection preferences can be accept automatic or accept manual. Finally, there's no bandwidth limitation imposed by PSC itself. Understanding these details will help you answer exam questions accurately. Thank you for your attendance. Please consider subscribing to the channel.